Hello everyone. Let us talk about acids and bases. Let us start first with the Arrhenius definition of acids and bases. According to Arrhenius, acids are substances that produce hydrogen ions or H+ when dissolved in water. Like for instance, HCl. HCl or hydrochloric acid will dissociate in water to form hydrogen ion. So this is the material that makes HCl an acid. And bases are defined as substances that produce hydroxide ions, OH-, when dissolved in water. For example, sodium hydroxide in water will dissociate into sodium ion and hydroxide ion. So this material is the one that makes sodium hydroxide a base. There are other definitions, but for now, we consider only the Arrhenius definition. Acid-base indicators, also known as pH indicators. These are materials that change color in response to changes in hydrogen ion concentration or a change in pH, since pH is a function of hydrogen ion concentration. And pH is a quantitative measure of the acidity or basicity of an aqueous or other liquid solution. This is the mathematical expression for pH. Okay? pH is the negative log of etong bracket na to and bracket with H+ inside the bracket means hydrogen ion concentration. Or you can also express pH in this manner. Log 1 over the concentration of hydrogen ion. That is described as the decimal logarithm of the reciprocal of hydrogen ion activity or hydrogen ion concentration. This is the pH scale from 0 to 14. And these are examples of common substances like food and chemicals and their position on the pH scale. Battery acid, that is very acidic, naa siya sa pH of 0. And sodium hydroxide solution, that is very basic, andyan siya sa pH 14. In the middle is represented by pure water. This is neutral, neither acid nor base. Materials with pH below 7 are acidic, and the most acidic is this pH 0 here. And if we go the opposite direction, we are going more basic. This is the most basic. Okay, so these are examples of acidic materials under approximate pH in the pH scale. Okay, again, an indicator. This one indicator, very common indicator, is the litmus paper. The litmus paper test, where we have a red litmus paper and a blue litmus paper. To perform the test, place a drop of liquid sample on a small strip of paper, or dip a piece of litmus paper in a small specimen of sample. In our case, we use the spot plate, where we dip the litmus paper into the small sample inside the depression of the spot plate. Ideally, we don't dip litmus paper in an entire container of a chemical, because the dye could contaminate a potentially valuable sample. So what we do, we obtain a sample, a small sample, place it in a container, and dip the litmus paper. So the litmus paper turns red when dipped in acidic solution. So this is a blue litmus paper dipped in acidic solution. This is acidic solution. It turns red. And the litmus paper turns blue when dipped in alkaline solution. This is a red litmus paper, and it turns blue. This is an alkaline solution. But of course, if your litmus paper is already red and you immerse it in an acidic solution, the color will remain red. And in the same manner, if your litmus paper is already blue and you dip it in alkaline solution, it will remain blue. This is a litmus paper test at various pH. Okay. So, dito, between pH 5 to 7, di ba, it is difficult uh, to tell if it is acidic or basic. Okay. Dito, it is obvious that it is acidic, pero banda dito, parang ang hirap tingnan if it is acidic or basic. That is because, okay, so this is uh, the range of color of litmus paper at various pH. Okay, this is 7. Sa banda rito, mahirap tingnan. Okay, dito is obviously basic, dito is obviously acidic, but in between, mahirap, it is difficult to tell. Okay, why is that difficult to tell? Pangitao na to ang litmus. Okay, because it changes color in this pH range between 5 to 8. So if your pH is below 5, that the color change is obvious. Okay, magiging, if it is below 5, magiging acidic ang reaction sa litmus paper. So blue to red. At if it is above 8, magiging obviously basic, magiging red to blue. But somewhere in between this pH range, mahirap tingnan ang color change. Okay? So, ito, dito sa range na to, dito mahirap tingnan ang color change. Ito naman is the methyl orange. Okay. So, the test tubes here are arranged acidic going basic. Again, for methyl orange, ang color change occurs between 3 and 4. So, etong test tubes na to are in this range. Okay? Between 3 and 4. If the pH of your solution is below 3, that will give you an obviously acidic reaction. So, magiging orange. If it is above 4, obviously na basic, magiging yellow. So, that is in the case of methyl orange. Because, arita sa methyl orange, okay, take note of its pH range of color change. Okay, andito siya sa 3.2 and 4.4. Below this range, obviously red. And above this range, obviously yellow. But somewhere in between, ito yung medyo mahirap tingnan. Phenolphthalein indicator. Phenolphthalein is colorless in acid and pink in base. Okay, tingnan naman natin ang color range or pH range ng phenolphthalein. Okay, so dito siya bandang 8 to 14, red siya. Below 8, colorless siya. Okay, so wala siya, yung neutral, parang acidic din ang kanyang reaction. Okay, kasi colorless pa siya at pH 7. It becomes pink when it get to pH 8. Okay. Dito naman tayo sa strong acid and weak acid. Acids are classified as either strong or weak based on their ionization in water. A strong acid is an acid which is completely ionized in an aqueous solution. Take note, ang ating indicator or basihan. Ang atong basihan, kung strong acid yan, is if it is completely ionized in aqueous solution. An example is HCl or hydrogen chloride, hydrochloric acid. This is completely ionized in water. Okay. A weak acid, on the other hand, is an acid that ionizes only slightly or partially in an aqueous solution. And acetic acid is an example of a weak acid. Now we recall the reaction we observe with aluminum. Aluminum strip placed in 1 molar hydrochloric acid and aluminum strip placed in 1 molar acetic acid. Pareho sila ng concentration, 1 molar, 1 molar, but HCl is a strong acid and acetic acid is a weak acid. Tanawa ang ilang reaction, mas maraming bubbles doon sa HCl. Mas mabagal ang formation of bubbles doon sa weak acid, acetic acid. Okay, so ito yung na-mention kanina, that strong acid, ang ating basihan, kung strong acid ba yan, is when it is completely ionized in aqueous solution. Weak acid if it is only slightly or partially ionized. Okay, these are examples. Okay, weak and strong acid. These are examples of weak acid. These are examples of strong acid. Sa base naman, meron din yung weak and strong base. Weak base, these are examples, and strong bases, these are the examples. And take note, sodium hydroxide is a strong base. Okay, we recall the solubility rule, the table that shows the solubility rule. These are the soluble compounds, and these are the exceptions. These are the insoluble compounds, and these are the exceptions. Okay, take note, kani. Okay. Insoluble ionic compounds, compounds containing hydroxides. Okay, na ay exception if it is calcium hydroxide, strontium hydroxide, and barium hydroxide. These are the exceptions, meaning soluble. Other hydroxides such as ferric hydroxide, chromic hydroxide, the ones that we used in the exercise, are insoluble, considered insoluble. Okay, so when you have ferric chloride added with sodium hydroxide, okay, it will produce an insoluble product, ferric hydroxide, which is a weak base. Okay, this is the reaction. We start with ferric chloride, a yellow-brown solution, added with sodium hydroxide, which is a colorless solution. It produces a brown color precipitate, ferric hydroxide, and the other product is sodium chloride. And the other weak base is chromic hydroxide. Chromic sulfate added with sodium hydroxide. This is the start before the sodium hydroxide was added. When you add sodium hydroxide, it forms this precipitate described as dirty green precipitate. But in excess of sodium hydroxide, the grayish green precipitate dissolves to give a clear dark green solution of sodium hexahydroxy chromium. Okay, so this is the grayish precipitate, chromic hydroxide solid, but if you add in excess, it becomes sodium hexahydroxy chromium, which becomes soluble.